In an alarming development that could shake the global aviation industry, the FAA has issued an emergency warning about potentially serious defects in critical components of several Boeing 787 Dreamliner aircraft. The proposed Airworthiness Directive, released on July 28, 2025, is a wake-up call about the integrity of the aerospace supply chain and the mounting challenges Boeing faces in maintaining its quality standards. So, just how serious is the issue with the 787? Could this lead to a global grounding? Let's find out. To fully grasp the severity of this warning, it's crucial to examine the core issue the FAA is addressing. At the heart of the current concern lies the components of the ram air turbine, RAT, installed on 9 Boeing 787-9 and -10 aircraft. These are not auxiliary parts. The RAT is an extremely vital system designed to automatically deploy in the event of a complete loss of main power on the aircraft. It provides emergency power to flight control systems and essential instruments, ensuring that pilots can maintain control and safely land the aircraft. A failure in the RAT could turn an already serious emergency into an unavoidable catastrophe. The crux of the issue is the discovery that these RAT components may have been manufactured using substandard titanium material. Instead of using Grade 5 Ti6Al4V aerospace-certified titanium alloy, approved and trusted for aviation use, the components were made from commercially pure titanium Grade 1 or 2. This difference is critically important. Grade 5 titanium is renowned for its superior strength, fatigue resistance, and ability to withstand harsh aerospace conditions. In contrast, Grades 1 and 2 titanium, while used in various industries, do not possess the mechanical properties necessary to operate in such a critical system aboard an aircraft safely. With the use of inferior materials, the FAA has issued a warning about potentially unpredictable and severe consequences. The agency cautioned that this substandard material could lead to failure of the RAT deployment mechanism. In other words, when the RAT is called upon in an emergency, it may fail to deploy, or worse, it could break apart during deployment. The potential outcomes are extremely serious: loss of backup electrical power, leaving pilots unable to control essential systems, or even the RAT detaching from the aircraft mid-flight, creating a large piece of debris that could further damage the aircraft or pose a hazard to people and structures on the ground. While the number of affected aircraft is currently limited, the nature of the defect, impacting a last resort safety system, makes it a top-tier safety concern that demands immediate and comprehensive attention. The concern extends beyond the technical defect itself, reaching into the origin of the substandard material and exposing a critical vulnerability in the supply chain. So what caused this? This could shock you. The low-quality titanium is believed to have originated in China and was supplied by Spirit Aerosystems, a key aerospace components provider for both Boeing and Airbus. This is not the first time that issues related to substandard materials have surfaced in the aerospace supply chain. The problem bears an unsettling resemblance to similar reports from 2024, when a global titanium shortage, partly due to Western sanctions on Russia, forced manufacturers to seek alternative sources. Under the pressure to secure new supply lines, it appears that quality control processes were either bypassed or not stringent enough. These supply chain decisions led to serious consequences as substandard materials were incorporated into critical aircraft components. Investigations have revealed that manufacturers sometimes relied on unverified or inadequately tested sources of material. These decisions, possibly driven by cost pressures or supply shortages, inadvertently introduced compromised materials into essential aircraft parts. This raises serious questions about aircraft manufacturers' ability to oversee and control their vast and complex supply networks. How could a non-compliant material, especially titanium, a core component of aerospace engineering, pass through multiple layers of quality checks and still end up installed in a commercial aircraft? Although the number of affected aircraft is currently limited, warnings from the supplier suggest that the problem may be far more systemic. The FAA's proposed directive is not simply based on a few isolated cases. It is based on multiple supplier notifications, a phrase that signals a potentially widespread issue rather than a one-off incident. This implies that many other components, or even other aircraft types, may also be compromised by substandard material that has not yet been identified. It remains unclear exactly how the faulty titanium moved through the supply chain, from raw material producers to component suppliers, and ultimately onto Boeing's assembly lines. This lack of transparency not only hampers traceability, but also undermines confidence in the entire process of aircraft manufacturing and parts tracking. So, do you wonder how Boeing responds? In the face of these warnings, Boeing initially responded, but its silence following the FAA's latest notice has raised serious concerns. The affected 787s were assembled at Boeing's North Charleston facility in South Carolina. In response to early alerts about the issue, Boeing issued an alert service bulletin on February 20, 25. This bulletin recommended that airlines inspect RAT components using non-destructive testing methods. Specifically, airlines were instructed to use advanced techniques such as high-frequency eddy current analysis and X-ray fluorescence spectroscopy to detect anomalies in material composition. While this step is necessary, the reliance on airlines to identify such fundamental material flaws points to a serious lapse in the manufacturer's initial quality control process. Not only Boeing, despite Collins Aerospace facing significant financial losses, both they and Boeing have remained silent in light of the FAA's most recent warning, an alarming stance given the implications for aviation safety. Collins Aerospace, the manufacturer responsible for the RAT devices, reportedly suffered financial damage amounting to $175 million in 2024 due to disruptions in the titanium supply chain. This figure underscores the seriousness of the issue and the massive costs involved in remediation. However, what is particularly troubling is that neither Collins Aerospace nor Boeing has made any public comment following the FAA's latest announcement. Such silence amid a major safety alert is difficult to justify. It raises questions not only about the company's transparency, but also about whether strict sourcing and quality assurance procedures were followed, or whether they were compromised by other pressures. The absence of a clear public statement from those involved risks further eroding public and airline confidence. Boeing and Collins Aerospace's failure to issue a transparent response at this critical moment may be seen as an attempt to manage the narrative, but it could also deepen doubts about their credibility. In an industry where safety is paramount, transparency and accountability are non-negotiable. This silence only intensifies scrutiny and skepticism over Boeing's ability to fully address its mounting quality control challenges. The Ram air turbine issue, while currently affecting only a small number of aircraft, carries immense significance for aviation safety because it impacts the aircraft's ultimate line of defense. Though only 9 aircraft are currently known to be affected, the implications for flight safety are profound and cannot be underestimated. The RAT serves as a critical last-resort power source in emergency situations. It is essentially the aircraft's final lifeline when all other power systems have failed. Any compromise in the reliability of the RAT, even if the scenario requiring its deployment is rare, presents a serious safety concern. In aviation, safety allows no room for compromise, and the mere possibility that such an essential emergency system could fail due to substandard materials is a nightmare scenario for any pilot, airline, or passenger. Besides, the potential consequences of a failed RAT are varied and catastrophic. First, if this part fails to supply adequate emergency power, pilots may lose the ability to operate critical flight surfaces, hydraulic systems, or electronic equipment, potentially resulting in total loss of control. Second, should it detach mid-flight, it could inflict severe damage on the aircraft's structure, engines, or other vital systems, potentially leading to a disastrous crash. Even if no accident occurs, a failure of the emergency power system could still trigger intense panic among passengers, especially if it results in the sudden loss of lighting, communications, or cabin functions. For airlines, the issue extends beyond safety concerns to significant operational and financial disruption. Carriers operating affected Boeing 787-9 and 787-10. Aircraft may face considerable short-term scheduling disruptions. Identifying and inspecting suspect parts and replacing them if necessary will demand time and resources and may result in the temporary grounding of affected aircraft. This leads to financial losses and inconvenience for thousands of passengers. The incident may also prompt a broader reassessment of titanium sourcing practices across the aviation industry. Regulators worldwide, not just the FAA, are likely to investigate the extent to which aerospace manufacturers have relied on alternative titanium sources. This situation would drive sweeping reviews of supply chain controls and increase pressure on manufacturers to provide greater transparency regarding the origin and certification of their materials. Stricter regulations for material inspection and approval, particularly for safety-critical components, may follow. Notably, this incident comes at a time when Boeing is already under intense scrutiny over a series of quality control and manufacturing issues across multiple commercial aircraft programs. From fuselage problems in the 737 MAX to production irregularities in the 787, Boeing's reputation has taken repeated hits. The 787 in particular has faced heightened oversight following prior quality concerns and the AI-171 disaster. The rat issue is merely the latest blemish on an already troubled quality record. Looking ahead, the FAA's proposal calls for immediate corrective action, but the deeper concern lies in how this impacts Boeing, particularly its troubled 787 program. While the directive will go through public review before becoming an official airworthiness directive, once implemented, it will require urgent inspections of rat components on 9 affected Dreamliner aircraft. This places additional operational and reputational pressure on Boeing, especially as airlines and maintenance crews rush to comply ahead of peak travel season to avoid major service disruptions. Beyond the technical repairs, this incident highlights a broader and more troubling trend affecting Boeing's supply chain: systemic lapses in quality control. As global aviation ramps up, the 787, already marred by delays and repeated issues, becomes a symbol of how supply chain weaknesses, material shortages, and geopolitical strains threaten production integrity. The days of reacting after failures are over. Boeing and its partners must now prove that every component meets uncompromising safety standards from the ground up. As the investigation unfolds, the spotlight must intensify, not only on Boeing but also on suppliers like Spirit Aerosystems and Collins Aerospace. These aren't isolated flaws. They point to deeper, unchecked risks that demand transparent audits, stricter sourcing oversight, and a commitment to safety that goes beyond internal reviews. For Boeing, the challenge is no longer just fixing a part, it's fixing a mindset. Restoring trust in the 787 requires more than patches. It demands a shift in culture where safety trumps deadlines and earnings. Without this shift, incidents like the rat issue won't be the last entry in the growing list of 787 setbacks.